Hello, Algebra 2. This is our last topic overview from previous units as part of our Day 6 notes in Unit 6. And we're reviewing the quadratic formula. Now that we've been using radicals, we can simplify anything other than a perfect square once we get our quadratic formula. And this is on the third page of these notes, so we'll be talking about the essential question of number 3. Can I simplify radicals after using the quadratic formula? And it's also a really good topic. Can I use the quadratic formula? Hopefully this will help everybody remember how to use it. First of all, remember that the quadratic formula is solving for the solutions. So they could be real solutions or imaginary solutions, and that's what we're solving for. If they're real, they're x-intercepts or zeros, and if they're non-real solutions, then they'll be non-real roots. You can have real roots, real zeros, and real x-intercepts. They all mean the same thing with our solutions, but you can only have non-real roots. Okay, so let's get right into it and remember the quadratic formula. This formula is given to you on all the tests. It's not something you have to memorize. You can, and it doesn't hurt, but it is given to you. And it's most important to understand how do you use it, and all of your quadratic functions must be in standard form. So standard form, remember, is ax squared plus bx plus c equals 0, because we're trying to find when is this function equal to 0. So you want before you start, you must put your quadratic equation into standard form. And by standard form, I'm meaning ax squared plus bx plus c equals 0. Our second step is plugging in first I'm going to write down my a, b, and c, and then I'm going to plug them in to my quadratic formula. So plug into the quadratic formula. And our last will just be to simplify. So these are our steps. We have 3 steps, and let's try the first problem here. So for number 1, we already have it in standard form. We have everything on the left side, and it's simplified. So we have ax squared plus bx plus c. So number 1 is already in standard form. So step 1 is finished. So I'm going to go ahead and write number 1 in the problem down. And that step 1 is already all set. Okay. Step 2 is going to be writing a equals, b equals, and c equals. So for our problem number 1, our a, again, is the number in front of the quadratic, so the x squared term. So a is equal to 2. Our b is the number in front of the linear term, so our b is 4. And then our c is our constant. So there's our a, b, and c. So if it's out of order for some reason, you must put it in order to pull out the correct a, b, and c. So this is part of step 2, and now we're going to plug it into the quadratic formula. So I'm going to take a and plug it into all the a's here. There's 2 spots for a. B, we're plugging into the 2 spots for b, and then c, there's only 1 spot. And we always plug in using parentheses. So here's our quadratic formula. X equals, so negative b, so negative 4, plus or minus b squared, so 4 squared, minus 4 times our a times c. And then everything is all over 2 times a. So 2 times, and in this case, a is 2. All right. Everything should be plugged in now. I want you to go ahead and try to simplify on your own and then bring it back. Okay, so when you went to simplify, you start with what's in the inside of the square root, and you should get 16 plus 40. Then 16 plus 40 would add to 56, and then we're going to look to simplify that radical. We're looking for perfect squares or pairs if you're using the jail method. And the first thing I thought about with 56 was 2 times 28, and then 2 times 14, and 2 times 7. So 56 then would be equal to 2 times 2 times 2 times 7. And I just wrote that here. And there's a pair here of 2's, or if you think of the perfect square of 4, and that gets simplified to 2. The 2 and the times 7, these two have to stay inside, so I just multiply them again as 14. Okay, the rest is just going to come down the page as you're working through the problem. Now our radical is simplified, but we have to think about our fraction here. So both items are being divided by 4, so I could divide negative 4 divided by 4 to get negative 1, and I also can divide 2 by 4 to get 1/2. And I have two answers here for my quadratic formula. Negative 1 plus or minus 1/2 times square root of 14. Okay, now let's remember what this means. If we look at the graph of our function, so I just plugged in my quadratic equation, the one we just solved for the quadratic formula, 2x squared plus 4x minus 5. Remember, we're solving for the solutions. So here we had two real solutions, and here's one real solution that I calculated, just hitting the second calc button and found that 0. And we could do the same for the second one. And this is a good way to check your quadratic formula, to use the calculator to check. And so this value said it's 0.87. So let's go over and look at this radical again. So negative 1 plus or minus 1/2 times square root 14. Let's think about so this is negative 1 plus or minus. Let's multiply 0.5, that's 1/2, times square root of 14. Go ahead and try that in your calculator. Okay, you should have gotten 1.87. So the one that we found in our calculator was the negative 1 plus 1.87. That is 0.87. That's what I found in my calculator. The second one we should be able to find be negative 1 minus 1.87, and that's negative 2.87. So when you're solving using a quadratic formula, I want you to leave it like this, but I also want you to understand what it means. And there's what you're finding, what the radical means. There's the 0, it's at 0.87, a number close to 1 but not to 1, and our second 0 is at negative 2.87. So a good way to check is to use your calculator and see if your radical simplifies to the same values that you would get if you calculated it using the calculator. So this would be your answer that I would expect if I wrote it on the quadratic formula. In addition, if you're using if it's on the multiple choice, you could calculate it using the calculator and then look at each radical to see which one would be equivalent as you're working through the problem. Okay, let's look at problem number 2. So problem 2 is a little bit different in that it's not in standard form, so we have to do step 1. So step 1, remember, is put it in standard form. and step 1 is moving everything to the same side and put it in standard form. So this, it's not set equal to 0, so we have to subtract 4 from both sides. They set equals 0, and then simplify. So then we have x squared plus 4x minus 1 equals 0. So now for step 2, for problem number 2, we're going to say that a is equal to, in this case, 1. There's no number in front of the x squared, so technically there really is a 1 there. And then our b is 4. That's the number in front of the linear. And then c is negative 1. And we can't find our a, b, and c until it's in standard form, or we will have this incorrectly done. So now we plug into the quadratic formula. So x equals negative b, so it would be negative 4, plus or minus b squared, minus 4 times a, in this case it's 1, times c, in this case it's negative 1, all over 2 times a. Alright, go ahead and pause and try to simplify your quadratic formula and then bring it back. Okay, so you should simplify inside the square root first, and 16 minus 4 times 1 times negative 1 would be 16 plus 4, and that's 20. So then we have the square root of 20. We know there's a perfect square of 4 in there. So square root of 4 is 2, so that comes out, but that 5 stays in. Remember, 20 is 4 times 5. Then everything is still being divided by 2, so each item we could simplify by dividing by 2. So negative 4 divided by 2 would be negative 2, and 2 divided by 2 is 1. So our final answer is negative 2 plus or minus the square root of 5. And again, if you're going to confirm using your calculator, you would bring it up in the calculator, find the zeros, and this is the right answer on the paper version of the test, but you can confirm should be getting 2 real values. One is 0.24 and the other is negative 4.24. And if you add square root 5 to negative 2 and subtract square root 5 to negative 2, you would get that. And your calculator can help you confirm that. Alright, for number 3, I want you to go ahead and try the whole problem by yourself. Make sure you do step 1, it's not in standard form here, and then step 2, and then go ahead and simplify. Okay, so for the number 3, our first step was put in standard form, so you had to subtract 4x from both sides. And then you're writing down your a, b, and c value. And you should get a is 1, b is negative 4, and c is 7. So now you plug in the quadratic formula, and you're getting a negative 4 would make a positive 4, plus or minus, for b squared we have negative 4 squared, which would be 16, and then negative 4 times a times c would be negative 4 times 7, that would be negative 28, all over 2a, so 2 times 1 is 2. Alright, so then we're going to simplify our radical. 16 minus 28 would be negative 12. Then we look to keep simplifying that radical. So negative 12, remember, would be negative 1 times 4 times 3. The negative 1, remember, is I. The square root of 4, the square root of negative 1 is I. The square root of 4 is 2. And the square root of 3 is not a perfect square, so we'll leave that inside. So we pull out the square root of negative 1 and the square root of 4, and we'll have 4 plus or minus 2i square root 3 all over 2. Our last step is to divide both items by 2, and we get 2 plus or minus I square root 3. Now our non-real solutions, this is a non-real root, won't show up. So when you graph this in the calculator, you will get no real solution. So let's look at what that looks like. So if you were to plug it in, it's not going to cross. So here you have to know the quadratic formula to get